Hello everyone, I am Shamima Sultana Sonia, and today I'm really excited to talk about something I find fascinating: blockchain based identity systems, a decentralized future. We all interact with digital systems daily, logging into apps, verifying our identity, sharing personal information, and while this might seem routine, it actually hides a lot of risks and inefficiencies. In this presentation, we will look at how blockchain technology can reimagine identity management, making our online lives more secure and private, and possibly redefine digital trust in the future. So here's what we will cover. We'll start by understanding what's broken in our current identity systems and why that's a big deal. Then I will introduce blockchain-based identity management, how it works, what technologies power it, and how it's being used in the real world. After that, we will explore how this solution addresses today's issues, what new possibilities it creates, and what ethical and legal questions it raises. And finally, we will look ahead at future trends, opportunities, and what needs to happen to make this vision a reality. Now, I want to talk about why identity is such a critical issue. Most of the identity systems we rely on today for banking, healthcare, education, and even government services are centralized. This means your personal data is stored in large databases controlled by single organizations. The problem is these systems are extremely vulnerable to cyber attacks. A single breach can leak millions of identities, and we have seen that happen again and again. But even beyond security, this system don't give users much control. Once you hand over your data, you really don't know how it's being used or shared. Also, identity systems are fragmented. You have to verify yourself again and again across different platforms. That's not just annoying, it's inefficient and risky. So the big takeaway here is we need a better, safer, and more user-centric way to manage identity. Here's where blockchain comes in. Instead of relying on a central authority to store and verify your identity, blockchain uses a distributed network where trust is built through cryptography and consensus. There are a few core concepts we should know. Decentralized identifiers, or DIDs, are like usernames that belong only to you and no one else can control or change them. Secondly, verifiable credentials are digital proofs of identity like a driver's license or university degree, but signed cryptographically so others can verify they are legit without contacting the issuer. Thirdly, smart contracts are little pieces of code that can automate identity verification or enforce privacy policies on the blockchain. Together, these tools let users own their identity, manage what they share, and protect their data, all without relying on a central provider. Let me walk you through a typical workflow. First, the user creates a decentralized ID and stores their credentials. For example, a university issues a digital diploma to a student. Later, when the student applies for a job, the employer can verify the diploma through the blockchain without ever contacting the university. The student only shares what's needed, not their full transcript or personal information, just the proof that they have been graduated. And if they need to update or revoke a credential, that can also be done securely through the network. This process is faster, more private, and much harder to fake. Now let's look at some real-world examples. Microsoft ION, built on the Bitcoin blockchain, is being used to create decentralized digital identifiers or identities for applications like LinkedIn. Sovrin is a public permissioned network dedicated entirely to self-sovereign identity, and it's supported by global nonprofits and institutions. On the government side, Estonia's e-Residency program allows global citizens to create a government-backed digital identity to access Estonian services. In India, the Aadhaar system is being enhanced with the blockchain security to protect the identity of over a billion people. So these examples show that decentralized identity not just a theory is happening. This new approach addresses many of the pain points we talked about earlier. First, it eliminates the single points of failure. Since there's no central server to attack, it uses strong cryptography to ensure that data is real and untampered. Users finally get control over their own identity, choosing exactly what to share and with whom. It also works across platforms. So once verified, your identity can be reused anywhere. However, it's not without limitations. Public blockchains can be slow and expensive to scale. Legal compliance is tricky, especially with strict laws like GDPR, and convincing large organizations and their governments to adopt a new system takes time and trust. One big insight here is that we don't have to rely on central authorities anymore. Trust can now be established through technology, not institutions. Identity becomes portable, cryptographically secure, and fully owned by the user. This opens up space for innovation. For example, building new systems where users can log in, share credentials, or prove who they are without passwords, forms, or verification delays. Now I want to paint a picture of what the world might look like the blockchain identity fully adopted. In financial services, KYC would be done once and securely reused across all banks. In healthcare, patients could control access to their records, switching hospitals without starting over. In voting, identities would be verified and protected, reducing fraud and boosting trust in elections. Even in the Internet of Things, devices could have verifiable identities, which would improve automation and reduce cybersecurity risks. And as these systems grow, we will see a shift in policies and regulations to support decentralized identity on a global scale. Of course, with great power comes responsibility and complexity. First, who owns the data in a decentralized system? It's technically user controlled, but what if governments or companies disagree? Legal compliance is another big concern. Blockchain is immutable, but laws like GDPR require that users can delete their data. That's a contradiction we need to resolve. There's also the risk of misuse, fake credentials, identity fraud, or surveillance if the system isn't properly designed. And finally, trust and adoption. Will traditional institutions be willing to give up control and move to something this different? That's still an open question. Looking ahead, I think the future is promising. Scalability is improving thanks to layer 2 technologies and more efficient blockchain architectures. We're also seeing exciting integration with AI and IoT, enabling devices and systems to interact securely and autonomously. Governments and enterprises are beginning to experiment, especially in areas like banking, governance, and global travel. All of this moves us closer to global decentralized identity standards that are both secure and user friendly. To quickly summarize everything, traditional identity systems are flawed, they are centralized, insecure, and give users little control. Blockchain offers a more secure, decentralized alternative, giving users ownership, improving trust, and enabling interoperability. It's not perfect. We still face challenges with regulation and scalability and adoption. But if we invest in research and pilot projects, we can build systems that truly protect digital identity and empower users worldwide. This presentation is based on current research, including this article by Rodionov, which explores the technical and legal possibilities of decentralized identity systems. Thank you so much for your attention. I love to hear your thoughts and answer any questions you might have.